Hello dear students, welcome back. So as you know that we started modern physics, right? And yesterday was a first lecture of modern physics in which we discussed about the sections of modern physics, how many numericals, the weightage of the modern physics. Plus, we started with the photon theory. So today most probably we will end the photon theory and tomorrow we will start photoelectric effect. Okay, so let us start now. Let's start now. Once again, let's start now, class. I hope my screen is very visible to you and my audio is clear to you, right? Okay. Look now. So today we will be starting lecture number 2. Okay. So we will be starting whole thing this lecture with the first numerical. And numerical you can see on the screen is we are having 2 milliwatt laser operates at a wavelength of 500 nanometer. Calculate the number of photons that will be emitted per second. So I guess if you notice it from this figure, what is given to us? That power is given to us and it is 2 milli. Milli means 10 to power minus 3 watt. Wavelength means lambda. Lambda is given to us and it is equals to 500 nano. Nano means 10 to power minus 9 meter. And we have to calculate n. Small n. Small n means it is n by t. N by t, which is equals to p lambda divided by hc. What is p? P is 2 into 10 to the power minus 3. Lambda is 505 into 10 to the power 2 minus 9 whole divided by h. H is 6.6 10 to power minus 34 into 3 10 to the power 8. Done? I can write 5 to the 10. It came out to be 10. So 10 power 1 minus 3 plus 2 minus 9 whole divided by this particular thing means 2 10 to power minus 25 as per yesterday calculation. So look now, it is 10. 3, look, 2 plus 1 is 3. 3 cancel out. We are having 9 now. 10 to power minus 9. Then it is plus 25 divided by 2. 1 by 2 is 0.5. I will write 0.5 multiplied by 10 to power 25 minus 11. Sorry, 25 minus 9. 14 minus 14. Or I will write it as a 5 10 to power minus it's plus 15. No? Sorry, plus 15. So as you can see that option number 4 is my answer. You will find this type of numerical in your examination and you need to be very good with the calculation part. How it is to 10 to power minus 25 in yesterday's class when you will do the calculation of 6.6 10 to power minus 34 into 3 10 to power 8 you will get 2 10 to power minus 25. Done. Next numerical you can see here monochromatic light, that means only one frequency is available, that is 6 10 to power 14 hertz, is produced by a laser. The power emitted is this much, so we have to find out photon per second on an average. Okay, photon per second. So what we have to find out? Photon per second, that means n. Small n is given to us, we have to find it out. But look now, in this particular scenario, my power and frequency is given. So we have one more formula, power equal divided by h times nu. Power is how much? It is 2 10 to the power minus 3 divided by h. H is 6.6 10 to power minus 34 and frequency is 6 10 to power 14 hertz. Done? So I will write 6 divided by 6.6 is 20 by 3 multiplied by 6. So where I have a 10 to power minus 3, then minus 14 plus 34. So I can write 3 ones are 3, 3 twos are 6, 2 and 2 cancel out. So we have 1 divided by 2, 10 to power minus 1, no plus 1 here. So upon where I have a 10 to power 13 minus 16 plus 34. So I will write it as a 0.5 multiplied by 10 to power minus 16 plus 34 plus 1. So you can write it as a 5 into 10 to the power 15. Option number A is correct one. Easy calculation, easy numerical, but you need to think about which particular equation you need to use. Whether you can use P lambda by Hc or you can use P divided by H nu. Now third numerical. Okay. Third numerical, like from a bulb of 40 watt. So we are having a bulb with 40 watt. That means power. Power is given as 40 watt. Done. How many quanta particle of wavelength lambda? So lambda is given as it is 0.4 10 to the power minus 6 meter per second. So we have to find out n. But here the power that is useful to us now, that is only 10%. 10% of 40 watt equals to 10 divided by 100 into 40. Cancel out. So we are having 4 watt only. 4 watt. So what is n now? N is P lambda divided by Hc. P is 4. Lambda is 0.4. 10 to power minus 6 divided by Hc is 2. 10 to the power minus 25. 4 for 16. We are having 1.6 divided by 2. 10 to power minus 6 plus 25. It is 0.8. So it is 8 10 to power 18. This is my answer. You can cross check my answer. Easy or super easy? I guess this particular numerical section is very easy, right? Only the equational thing you need to remember. Rest everything is very similar and simple to you. Okay, next. Okay, we don't have a numerical now. Let us start a topic known as intensity. Next topic is intensity, and if you remember, we completed the same topic in our EM waves. So intensity, that means capital I, intensity is nothing, it is equals to energy per unit area per unit time, and energy per unit time is power per unit area. Power is watt, area is meter square. So we can also write the whole thing as a energy flux also. Energy flux. Done? Look now. Look now. What is intensity? What is the formula for intensity? Intensity is energy. Energy is h nu. Area is A. Time is t. If we are talking about n number of particles, so I will write n h nu divided by at. We can write 1 second, beta. 1 second. Okay, so we can write n h nu divided by a t. So if I can write it as a I divided by n equals to h nu divided by at. I can write it as like this also, or I can write it as a n divided by at equals to I divided by h nu. Done. And we know that c equals to nu lambda. So nu equals to c by lambda. So I will write it as a I divided by hc into lambda. Done. So these are some formulas that you need to remember by anyhow. These are some formulas that one need to remember anyhow. This much, right? So intensity. Intensity means it will be n divided by at equals to I by h nu, that is I lambda divided by hc. These are some formulas, no? So the most appropriate would be this much. If you don't like to write this much, so don't worry about it. Easy now? So now, second topic that you need to write, and that is 1 second. Okay. So here is one more topic, that is radiation pressure. Radiation pressure means whenever we are having a light falls on some particular thing, there is a change in momentum. Change in momentum means there is a pressure due to the change in momentum. So we are having cases. Case number first, 100% absorption. 100%, or first of all, if you have written in your examination, that is 100% reflection. You can also write na reflection also. Absorption in one case, second is reflection. That means if we are having any sort of material, any like this, okay, now light falls on it. Light falls on it like this. Okay, reflection means it goes back also. It goes back also, no? Yes, sir. Look now. So this one I can write, sir, is it P I cap? P momentum plus I cap. P means momentum. What is the equation for this one? Sir, it is this one, no? It is P, it is minus J cap. Sorry, minus I cap. Minus I cap. So what is change in momentum? Change in momentum would be momentum final minus momentum initial. Momentum final means it is P minus I cap minus P plus I cap, which is equal to minus 2p I cap. Done? Done? minus 2p ik. Done now. But what is p here? What is momentum? Any idea what is momentum? Is it h by lambda? So therefore, I can write delta p. It is mod only. No worries about it is sign. So I will write 2h by lambda. Whenever your light strikes on any surface and it is getting 100% reflected, same case you have done in your NLM. Okay, it is 2h by lambda. If n number of photons, n number of photons, n number of photons. So therefore, change in momentum equals to 2nh divided by lambda. 2nh divided by lambda. Done. So if you are done with this case, we know one case from second law. From second law, we know that, what we know that? We know one thing, that is force is equals to delta P by delta T. I will write it as a 2nh divided by T times lambda, and h by lambda is small n, so I can write small n 2h whole divided by lambda, or I can write 2nh divided by lambda. This one is for momentum, this one is for force, this one is for force. But this case is for 100% reflection if we will deal with absorption. If now we will deal with absorption. Absorption. Absorption means if a light is falling, absorption means if we are having something like this, no? Look, it is something like this, and if light is falling on it, if light is falling on it, there is no reflecting back, nothing like that. So you can write delta P. Delta P is only P I cap. P I cap only. It is P I cap only, which is equals to h by lambda. If n number of particles present, that means n h by lambda. If we want to write force, so force is equals to small n h by lambda. Done. So we are done with this case, absorption and reflection. Look now, in some places you will find the manipulative work of it. Some places. What is F? What is F? Is it 2nh divided by lambda? What is small n? Small n is equals to P lambda whole divided by hc. Place this value, so F equals to 2h by lambda. In place of n, I will write P lambda whole divided by hc. Lambda, lambda cancel out, hs cancel out. So my answer came out to be how much? Is it 2p by c only? And intensity. Intensity is equals to power by area. So power came out to be intensity into area. So I will write here it is 2IA divided by C. So at the end, the final answer that you need to remember, that force is equals to 2nh whole divided by lambda equals to 2p by c, which is equals to 2IA by c. One parameter, three different formulas, so that we will tackle the three different problems in a one particular thing. Done? Easy or super easy? Easy or super easy? Easy, no? Okay, now let us start one numerical. Numerical state is that my numerical is like, one second, I don't know the highlight portion. Yes, this is my highlight one now. You can see here. Look now. Wavelength is 500 nanometer. Perfectly reflecting surface. Perfectly reflecting surface simply indicates what? 100% reflection. 2nh lambda, right? If the magnitude of average force is 2 micronewton, find number of quanta per second, that means small n. So we have to find out small n. How we will find small n? How we will find small n? Look now. F equals to 2n h whole divided by lambda. So what is given to us? 2 nh by lambda. I will write in a very good way now. Is it 2 and 1 second, 2 and h by lambda. Force is 2. 2 10 to the power minus 6 equals to 2 n we have to find out h. H is 6.6, 10 to power minus 34. Lambda is equals to how much? 500. 500 10 to power minus 9. So n came out to be 2 cancel out. It will be 5, 10 to the power minus 9 plus 2 minus 6 divided by 6.6, 10 to power minus 34. So I can write 5 divided by 20 by 3, 10 to power minus 9 minus 15 plus 2. Here is minus 34. So I will write here 15 by 20, 10 to power minus 13 plus 34. 5 3s are 15, 5 4 is 20. It will be 3 by 4. 3 by 4, 10 to power 1 to 21. So it will be 0.7, something like that. So I can write 7.5, 10 to power 20. N. This one, no? Super easy. So by this one, we conclude that how to find n if a force is given to us. Second numerical is a good one now. This one is a good one now. I request you to just please just think about it at once. You will find a clue. So here we are having this plate. Okay. It is having a mass m. If mass is m, so you know that it is gravity will be downwards, mg. It is in equilibrium, that means some force is acting upwards. Some force is acting upwards. Done. So what we have to find out? Power. So look now, what is force now? Is it 2p by c? This should be equals to mg, then only words it will be balanced. Balanced condition. Balanced condition. It is perfectly reflecting, that means 2p by c. Either it was a p by c. So what we have to find out? Power, no? So power is equals to mgc whole divided by 2. M is 10g. That means 10 gram. 10 to power minus 3. Done. G is 10. It is 3 into 10 to the power 8 whole divided by 2. So I can write, look, 1, 2. So I can write 2 plus 8, 10. 10 minus 3 is 7. So I can write here 3 by 2, 10 to power, look, 1 to 8, 7. It is 7. So 2 ones are 2, 2 ones are 2, 1 cancel out, 2 5 are 10. It is 2.5, 1.5. 1.5 10 to the power 7 or 15 10 to the power 6 watt. A good numerical. A good numerical. Next numerical now. Next numerical is like energy flux, okay, intensity of 50 10 to the power minus 3 watt per meter square incident normally on a perfectly reflecting surface of area this much. Perfectly reflecting, done. So force. So what is force now? What is force? Is it 2IA divided by C? Yes, 2 is 2. I is intensity, that means 50 10 to the power minus 3. Area is 15 centimeters square 10 to the power minus 4. C is 3 into 10 to the power 8. So 3 1 are 3, 3 5 is 15. So 5 to the 10. 10 into 5, it is 500. So 500 10 to the power minus 3 minus 4 minus 8. So 8, 6, 13. Okay. So 5 into 10 to the power minus 13 Newton is my answer. Easy one. Okay, red is not visible to you. I will just change the color. I will write whole thing. Okay. So look, F equals to 2IA by C. I will change the pen also so that it is visible to all of you. Then I will write here 2 into 10 50 10 to power minus 3 15 10 to power minus 4 divided by 3 into 10 to the power 8. My answer came out to be 5 10 to power minus 13 Newton. Next one. This one now. It is same, no? Same numerical. Okay, this one now. This one numerical is from your IIT. Okay. This numerical is from IIT. And more than one correct. More than one correct. Correct. So small, so we are having a mirror hanging in this way. Initially it was here, but sometimes it goes here, right? This is my mirror. You are reflecting a force here, it's angle theta. You are giving a force here, so force will ultimately go there. Force is how much? Twice AI divided by C. This is angle theta, so this is angle theta. This is T. So this would be T cos theta, and this would be T sin theta. Mass mg would be downward, so you will write T sin theta gets balanced by 2IA divided by C, and T cos theta gets balanced by mg. That is, divide both them, T cancel out, it will be tan theta. So tan theta is equals to 2IA divided by CMG. 2IA divided by CMG. Done. So then what is force now? What is force? So we have to find out pressure now, not force. So what is pressure now? Pressure. Force per unit area. Force is 2IA divided by CMG whole divided by area. A cancel out. So my answer came out to be 1 second. 1 second. 2IAC by MCG tan theta. Okay, it is not force. No, force is, we don't have any mg here. No, get confused. We don't have any. It is only, it's 2IA divided by C, whole divided by A. So my answer is 2I by C. 2I by C. Radiation pressure P. It is 2I by C. Done. 2IA CMG. Done. These two are correct option. And this one is from IIT. Okay. First one, second one. Both correct answers. Next numerical. A beam of light is incident normally on a plane surface, absorbing 70% light and reflecting the rest. If it is absorbing 70%, okay, so total is 100. 100 minus 10 watt, 10 watt. 70% and 30%. 70 of 100, 70 of 10 is 7. 30 of minus 3. 3 watt and 7 watt. 7 watt is absorbing, 3 watt is reflecting. Done? So what is net force? Net means it will be F reflecting plus F absorbing. F absorbed. What is reflecting now? Sir, it will be 2P by C. Absorbing means P by C. So I will take P by C common. Here we are having 3 now. So P, what is P now? No, we are having different P now. We are having different P. We cannot take P common, right? So 2P. What is P here? P here is 7 divided by C. Here is 3 by C. So I will write 1 second. 14 plus 3. 1 second. Reflecting is 3 only now. 3. This one is 7. 7. It is 6 by C. 7 by C. Okay, it is 6 plus 7 by C. 13 by C. Done. It is 13 divided by 3 into 10 to the power 8. Or you can write 13 divided by 3, 10 to the power minus 8. Easy or super easy? Okay. Look now. If we talk about photon, photon is a neutral species. Neutral means Q equals to 0. So do you know about electric force? Electric force, that is F equals to QE. So can I write F equals to 0? So not deflected by electric force. What is magnetic force? F equals to QVB sine theta. So F equals to 0. Okay. I can write here it does not deflected in electric and magnetic fields. One more point, in vacuum, all photons travel with same speed. Next part, in any process, number of photons may not be conserved. Suppose the last point thing that I will just make you understand, right? Suppose we are having a metal, photon is striking the metal, electron gets ejected. So look, photon, electron. So we are subtracting photon, we are getting electrons. So here photon equals to not conserved. Conserved. Energy levels. Electron. We are giving photon. This electron will go up to this particular thing, right? After some time, it will come back and it will release energy in form of photon. So we are giving photon. We are giving photon. We are getting photon. So here photon equals to conserved. So in any process, photon remains conserved or it may or may not remain conserved. Okay. So by this thing, we almost completed the photon theory. Okay. Tomorrow, we will do lecture number 3. Up to then, thank you, beta. Bye. Good night. Okay. So I don't want you people to be bored now from the lecture series. So let us continue the lecture number 3 from tomorrow onwards. Okay. Bye, beta. Thank you. Good night. Bye.